nonlinear equations. Day 1. If you have graph paper, that would be the easiest thing to use in this lesson because we will be graphing. If you just have line paper, that's okay, but if you can somehow get graph paper before you take the notes for this lesson, that would help. Essential question: how do you determine if an equation represents a linear or nonlinear graph? So first thing we have to do is define what the word linear means. Linear, if you look at part of the word, is line. So the graph is a straight line. And if it's nonlinear, the graph is not a straight line. So that's going to be our goal for every question in the lesson today. We're going to graph equations and figure out, are they linear? Do they make a straight line? Or are they nonlinear? Do they not make a straight line? All right, here's our first one. We have a bunch of stuff on the left. So first our directions say to graph the equation, and then they give us an equation, y equals 2x plus 1. The two questions we have to answer on every problem today is it linear or nonlinear, and is it a function? Now if you remember, to determine if something is a function, we have to do the vertical line test. So that will help us figure that out, which we'll work on later. Let's start with graphing the equation. The first thing you need to do is make a t-table, which is on the right-hand side with the x and y. On every problem, it's easiest if you have some negatives, a 0, and some positives for your x values. Now keep in mind, you can choose anything you want. The x values are determined by you. The y values then depend on the x. And like I mentioned, I always want a couple negatives, 0, and a couple positives in each situation. If you wanted to, you could choose 10, 11, 12, 13, 14, 15, negative 3, negative 4, negative 5, negative 6, negative 7, but they might not give you as good of an idea of what the graph is going to look like. All right, let's start plugging our x values then into our equation. So I'm going to take all of these numbers and plug them in right here. So if I take negative 2, then I've got 2 times negative 2 plus 1. Now we're just going to do PEMDAS. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. I'm going to put that under the y column. Next one, I'm going to take negative 1, so I'm going to do the same thing, except right here I'm going to put a negative 1. So 2 times negative 1 plus 1, that's negative 2 plus 1, which is negative 1. Same thing for 0, 2 times 0 plus 1, 2 times 0 is 0, 0 plus 1 is 1. 2 times 1 plus 1, 2 times 1 is 2, 2 plus 1 is 3. And last, 2 times 2 plus 1, 4 plus 1 is 5. Okay, so all of these things I have in the table now are coordinate points, and I am able to graph all of them. That's what's going to help me figure out if my graph is linear or nonlinear. So let's start with the first coordinate point. Negative 2, negative 3. Remember, we always go left and right, then up and down. So left 2, down 3. I don't need to label them, just put the dot. Negative 1, 1, 0, 1, 1, 3, and 2, 5. 1, 2, 3, 4, 5. Oops, one more. So if you look at these dots, you can notice that it makes a straight line if I connect them, which means this graph is linear, because it's a straight line. then to figure out whether or not it's a function, I'm going to do the vertical line test. So if I draw a vertical line, my red line is intersecting my blue line once. My red line is intersecting my blue line once. My red line is intersecting my blue line once. If it's always once, then it's a function. So there are 4 parts to your answers on these questions. The first part is the table, second part is the graph, third part is writing that it's linear, fourth part is writing that it's a function. So there's 4 parts to your answer. All right, next one. This time our equation is y equals x squared plus 3. Everything else on the left is the same. We're going to answer the same 2 questions. I'm going to write in my x values, which are going to be the same as what they were on the last problem. So let's look back and see what they were. -2, -1, 0, 1, and 2. -2, -1, 0, 1, and 2. Now I'm going to start again by taking all of these and plugging them in to x. So -2 squared plus 3. -2 squared is like -2 times -2, which is positive 4. 4 plus 3 is 7. -1 squared plus 3. -1 squared would be positive 1 plus 3 is 4. 0 squared plus 3 is 0 plus 3, which is 3. 1 squared is 1. 1 plus 3 would be 4. 2 squared is 4. 4 plus 3 is 7. Now I have all 5 of my coordinate points. So let's graph them. -2, 7. 1, 2, 3, 4, 5, 6, 7. -1, 1, 2, 3, 4. 0, 3. 1, 4. 2, 7. If I connect these dots, it makes something that looks like a U, or it's called in math a parabola. I'm going to look at my parabola that is nonlinear. And if I do the vertical line test, it is a function. I draw my vertical lines in there. It will only intersect my parabola once each time I draw the line. Last one. Again, graph the equation. This time I have absolute value in my equation. I'm going to take my 5x values, so -2, -1, 0, 1, and 2, and I'm going to plug them into my equation. So the absolute value of -2 minus 3, remember I'm taking all of these numbers and plugging them in here. Absolute value of -2 is 2. 2 minus 3 is -1. Put that under the y column. Absolute value of -1 minus 3 would be 1 minus 3, which is -2. Absolute value of 0 minus 3. 0 minus 3 is -3. Absolute value of 1 is 1. 1 minus 3 is -2. Absolute value of 2 is 2. 2 minus 3 is -1. There are my 5 coordinate points. And now I can graph. -2, -1, -1, -2, 0, -3, 1, -2, 2, -1. This time our graph makes a V. Absolute value graphs will always make a V. Any with exponents will always make a parabola. So a V would be nonlinear, and it would also be a function because it would pass the vertical line test. Summary. The homework for this lesson is a graphing worksheet. You're going to need to get the worksheet from your teacher as well as a piece of graph paper.